lesson and on my camera for those online who want to see my face. Okay, hold on. All right, before we get started, hi everyone. Welcome to our Overmark Group Tuition WA2 event. So this event is actually mostly for our students, but since we're already hosting it, right, then we must as well open to the public. So just to give a brief introduction, hi, I'm Miss Eileen. As you can see here, I teach a lot of math. Okay, you might have to remember my name because later on I will need you guys to help me do a survey. So yeah, the survey will ask you to pick the teacher's name lah. So yeah, here's my name. Okay, as you can see, I teach a lot of math. I actually specialize in O-level and IPA math, but don't worry, I can still teach E-math. Okay, I have about 6 years worth of teaching experience, if anyone cares. So in a way, I'm not some random person just teaching. Like I know my shit, okay? So don't worry. Yeah, just more about me in case anyone wants to know like my background. This is what I studied. I teach a lot of math. I also study a lot of math. And the more important thing here is I want you guys to know that math is fun. All right. It might sound a bit like bullshitty at the beginning if you don't like the subject, but seriously, once you practice enough, do enough revision, you will get the hang of it. And once you start answering questions correctly, you wouldn't want to stop. It's like a momentum that you want to keep up and you will start to enjoy the subject. And how do you do well in math? You really need to practice questions and you really need to do revision. So after you finish like your math class in school or go for your math tuition, take maybe 10-15 minutes after every lesson to take a look at what you have written down, what you have learned in class. This 10-15 minutes revision, right, even though it's quite short, is really, it will solidify whatever you have learned during class, okay? And you will make sure you understand what you're doing. Don't just read blindly. When you revise, make sure you understand what you're reading, okay? And even though most of you here are not my students, in fact, all of you here are not my students, don't be shy to ask questions, all right? So any point in time later on, if you don't understand or if you have any question on what is being written on the screen, you can ask me. For those online, you can unmute yourself and write in the chat box. For those physically, you can just raise up your hand lah. But ask the question at the end when after I finish each question, so you all don't interrupt like the other students like trying to write down or anything. Okay, so yeah, just more about me to keep things lighthearted. I don't know whether you all know what's a Smisky, but I'm currently very obsessed with it. I waste too much money on it. Okay, and I like cute stationery and my students improving. So okay, I didn't bring it today, but I actually have a pink color Casio calculator. So yeah, but unfortunately for you guys, the pink color Casio calculator is not accepted for the O-level syllabus, okay, because there are extra functions in it, so you all cannot buy it. Please don't bring it into the exam hall. All right, and I like my students improving, and some things I dislike is bihun. Okay, I really hate bihun for some reason, and I don't like it when students are in doubt and they don't ask questions. Okay, I don't want you guys to come in, waste 2 hours, walk out even more confused. Make sure you clarify any doubts you have. Okay, then the key takeaways for today's lesson is we are going to be recapping a few key concepts for probability and data analytics, statistics basically, and some common mistakes to avoid. And this lesson today, hopefully you can also identify like some common question types and methods to tackle them. Okay, later I will say like, oh, this question is very common. Please make sure you know those are the common questions. And then there are certain methods to go and tackle them. I might also be going through some checking and tackling tips. Honestly, the checking, memorizing, and tackling tips is more for A math, okay? But E math, there are still tackling tips as well. So yeah, if you manage to catch it later on, great. If you need me to clarify anything, ask me after class. Okay, let's begin with today's session. So again, those that just joined online, you can access the materials today that we'll be using in the Zoom chat. If you cannot see the link or cannot access the materials, can let me know. All right, so we will start off with data analytics first. Okay, so basically, right, data analytics and probability statistics, they are all under the same chapter in math. It's like the chapter outside of algebra, outside of like your typical math looking questions. You are always looking at data and then they will ask you information about this chunk of data. Okay, everyone here should know what is mean median mode, right? If you all don't know, you need to go back to Sec 2 already. Okay, so mean median mode is basically your central measurement of central tendencies. Mean is like the average. But please don't be alarmed if the question says median and mode is averages. Okay, they describe median and mode as average. It's also a form of average. It's just a different way of getting this value over here. But or by default, when you see the word average, you should be thinking of mean. But don't be alarmed if you see median and mode being referred as averages. Okay, so mean is literally you sum up everything, you divide by the total number of objects. Median, be very mindful. You need to arrange your observations in ascending order. Then you pick the term right smack in the middle after you arrange everything in ascending order. It must be in ascending order. A lot of times, students forget to arrange it in ascending order, then they just pick a middle value. Cannot. You need to rearrange it in ascending order first. Okay? And mode is the thing that appears the most. Be mindful, there can be more than one mode. Some data sets that you see might have 2 modes, might have 3 modes. Basically, if for example, my data is 1, 1, 2, 3, 3. Okay, 1, 1, 2, 3, 3. Can you see 1 and 3 appears the most? So this data set, there's 2 modes, and the mode will be 1 and 3. Okay, there can be more than 1 mode. There can be 2 modes, 3 modes, 4 modes. It depends on the data set. Now, let's take a look at the definition of range. Okay, range is a definition that students commonly mistake what is the answer for. Range is always the maximum value minus the minimum value. Highest value minus lowest value. For example, if I tell you I have data ranging from 2 to 20, a common mistake that students will write for range is the range is 2 to 20, but no, the range is 18 because you must take maximum minus minimum. A range is a single number, okay? It's a single value, not like literally a bunch of numbers. Now, let's take a look at IQR. IQR is your interquartile range. It's basically your Q3 minus Q1. And where do you get Q3? It's the 75th percentile. 75th percentile means top 25%. All right, when we look at the word percentile, it's always looking from the bottom to the top. So 75th percentile is the bottom 25%, but at the same time, it is the top 25%. Yes? Any question? Okay. So remember, it's Q3 minus Q1. And something that is not written, oh, sorry, haven't finished explaining. Q3 is 75th percentile, Q1 is 25th percentile. Okay, and something that's not written over here is this thing over here. This is very important. Interquartile range, okay, is not a value you find for fun. It is the number, right? The answer for interquartile range tells you the dispersion around the median. Okay, when you see the word interquartile range, it is always with respect to comparing with the median. When you see standard deviation, it's the dispersion around the mean. So you're always comparing standard deviation with mean. Be very careful. Standard deviation is always dispersion around the mean. Interquartile range is always dispersion around the median. What does dispersion mean? Dispersion is actually the spread of the data. Okay, so when I tell you the interquartile range is maybe 5, I'm telling you that the value, the spread of the data around the median is 5. Okay, then same thing. If I tell you the standard deviation is 2, that means the value of dispersion around the mean is 2. Okay, this idea of dispersion is very important because you will see a lot of comment questions in this chapter. And when you see comment questions, it's always talking about performance or dispersion. Later, we will go through more of it. Everyone here know the formula for mean and standard deviation? You all should know. So how I like to remember standard deviation is, I always like to tell myself, is inside, quote unquote, square, minus outside, quote unquote, square. Okay, why? Because this square is inside. You square the x, you sum up everything, then you divide by the frequency. Whereas the one at the back is you sum all the observations, divide by frequency. Only after you finish everything inside, then outside, then you square. Okay? They are different things. If they are the same thing, you minus together, it will become 0 already. Then your standard deviation will be 0. Okay? So please know this formula. I'm quite sure this formula is not provided in your formula sheet. If it is, you can correct me. And actually, this thing, can you see is the mean? Do you all know that it's the mean? Okay, if you know that it's the mean, great. So this thing over here is the mean, then this whole thing will be the mean square. Okay? Everyone here know the formula for standard deviation, huh? Anyone here don't know how to use calculator to get standard deviation? Everyone here know? Okay, so later on, if anyone doesn't know how to use the calculator, please let me know. But it will be great if you guys have the yellow button Casio calculator, because the yellow button Casio calculator tells you a lot of information. All right, so if you have that, great. If you don't have that, then maybe you need to do some manual calculation on your own. All right, but everyone here know how to use the calculator method, huh? Okay. Now, let's take a look at the next two diagrams at the bottom. If I'm doing too fast or too slow, you can let me know. So the next two diagram, right, that you're seeing over here, the one on top is called a cumulative frequency curve or diagram. The one below is your box and whiskers plot. Be very mindful. From your cumulative frequency diagram and your box and whiskers plot, you can identify range, median, and interquartile range. Okay, but you can never identify the mean and standard deviation. Can see that? Okay, so don't be confused, thinking that you can identify mean and standard deviation if they give you these two figures only. Cannot. Okay, how do we identify range from the from the cumulative frequency curve? Okay, the y-axis is always the frequency axis. So the value axis is the x-axis. Can you see that? Okay, the range is not 160 minus 80 because of the axis. No. Okay, the range is 160 minus 80. This is the correct answer. But it is not because of the axis over here. It is because of where the curve ends. The curve ends at a maximum value of 160 and it starts at a value of 80. Can see that? So your range is 160 minus 80. Okay? You can also identify the frequency from the cumulative frequency curve. There are a total of 20 objects in this data set. Not because you see the maximum number here is 20, but because the curve ends at value 20. All right, sometimes the question like to trick you on, they put here like, oh, 30, but then actually there's only 20 objects. So the end is 20. Okay? Then how do you identify median from a cumulative frequency curve? Median is 50th percentile. So 50% of 20 is 10, right? So you draw one line, then go down. This is the median value. Same idea for Q1 and Q3. Q3 is 75%, right? So it's 15. Then you draw down to get your Q3 value. Q1 is 25%, right? So 25% times 20 is at the fifth observation, right? Then it's at the fifth observation. You draw down. Then this is your Q1. So your interquartile range is just Q3 minus Q1. All right? Everyone clear? Not clear? Let me know. Okay. One thing about cumulative frequency diagram, the word is cumulative, okay? Everything you see is accumulation, okay? This is where a lot of students make careless mistake. Tell yourself, when I say, for example, okay, hold on, let me use maybe this thing over here. Okay, let the x-axis be marks and let the y-axis be number of students. Can you see 130 marks is linked to, okay, I'm a bit blind. What is the value over here? It's a bit small. Hold on. Give me a moment. is linked to this thing over here. So this one is the 12th student. Okay, 12 and 130. When we say 12 students scored 130, this statement is absolutely false. This is a very common mistake. A lot of students will say 12 students score 130, but it's actually 12 students scored a maximum score of 130. So that means 12 students scored 130 or less. All right, because it's a cumulative frequency curve, you are accumulating all the data from 130 all the way to the score lower than 130, to the minimum value. So take note, okay, when you read a cumulative frequency curve, tell yourself, when you look at the frequency, it is not 12 students score 130, but 12 students score 130 or less. Okay, this is a common mistake. Always see this kind of mistake one. All right. Now let's take a look at the box and whiskers plot. Box and whiskers plot. Okay, your box and whiskers plot, your whiskers will tell you the minimum and maximum value, all right? And your box will tell you the interquartile range and the median, okay? There are 3 lines in the boxes. The middle line is the median, like middle, median, okay? And then your lower line is the lower quartile, which is your Q1. Upper quartile is Q3, okay? Same thing, from a box and whiskers plot, you can identify range, interquartile range, median. And cannot identify mean and standard deviation. Now, is there a missing page? Don't have. Okay, sorry, that means it's just like that. Okay, let's start off with the questions now. So, they ask you to, okay, you can try it on your own while I'm explaining. Find the range first. The range is pretty easy. It's just the maximum value minus the minimum value. So you just need to open your eyes big. Don't make any careless mistake. Make sure you spot the correct largest value and spot the correct minimum value. Okay? Now, part 2, median. Everyone here should know median is the middle value, right? But don't tell me middle value is 32 because it's right in the middle of the box. Please know, you need to arrange everything in ascending order first, then you pick the middle value. Okay, so why are there so many like on my box over here? It's because, right, when I list out my values in ascending order, I list every time I pick a number, I will cross it. I pick a number, I write it down here, I will cross it so that I will not miss out any data. Okay, then how do I check that I don't miss out any data at the end of the day? After I write down everything and cross it one by one, or something like that, I will go and count how many data points I have on my workings. I should count and there should be 15. If I don't have 15, it means that I miss out something or have something additional. Okay, so I would advise you guys to cancel things out while writing them in case you miss out anything. But take note, if you do any cancellation, please do it in pencil. Because if you do it in pen, what if you cancel wrongly? Then when you correction take, you change the question. All right? So everyone understand why you must list it out in ascending order? Can, Okay, so how do you identify the median? Generally, there are 2 methods that I like to teach students. The first way is the position method. Can you see there are 15 data points? So the middle position will be 15 plus 1 divided by 2. When you have an odd number of observations, the position of the median value, you must always take the number of observations plus 1 divided by 2. Okay? When there are odd number of observations. When there are when there are even number of observations, okay, when there are even number of observations, you don't need to do the plus 1. For example, if I have 14 observations, where will the position of the median value be? I will just take 14 divided by 2 is 7. Then the median value will be in between the 7 and the 8 position. Okay, it is slightly different. If there is odd number position, this is the position method formula. If there are even number of objects, this is the position formula. They are slightly different. Some schools might teach you, or some teachers might teach you a different formula to identify the position. They should be correct as well. So just choose whatever method you prefer, so long as you are comfortable and you understand what's going on. Okay, what I just mentioned is the position method. So because I know I have 15 observations, I plus 1, divide by 2, it means I need to look at my 8th object. So what is my 8th object? 1, 2, 3, 4, 5, 6, 7, 8. So my answer is 33 for median. Can see? Okay. Another method is what I like to call the cancelling method. Okay. Literally, you cancel back and forth in an orderly fashion. Okay. It must always be back and forth. You cannot skip. Okay. Then the last number remaining will be your median. So this is another method. But take note, this cancelling method, if you have like 100 observations, are you going to cancel 100 objects? No. So also go and learn the position method. Okay. 2 methods over here. See which one you prefer, which one you are more likely to score in. Use that method. All right. Now, part 3, interquartile range. Interquartile range, right, is where things get a little confusing when you're trying to identify Q1 and Q3. Okay, let's take a look at this example over here. Can you see 33 is my median and it's a perfect median? I know sometimes you guys definitely have come across the question whereby the median is actually the average of the 2 numbers, right? When it is the scenario whereby the median is a perfect number, how do you identify the Q1? Tell yourself, delete this from the data set. Okay, like remove it, put it one side first, but don't throw it away. Just put it one side. The data in front of the median will be your refresh data set. Then the median of the front data, that is your Q1. Okay? Same thing. You throw 33 away, right? Now we take a look at the behind data. The median of the behind data, that will be your Q3. Can see that? Okay, so you throw away 33 because 33 is your perfect median value that you have found in II. But if you are doing those questions whereby there are even number of observations, when the median is shared across 2 values, you all know what I'm talking about? For those questions, you cannot throw the median away. You must cut the median, okay? The 2 numbers, you split the 2 numbers up. The first portion of the data, the smaller numbers, those will form your front data set. And then the median of the front data set, that will be your Q1. All right? And then the median of your behind data set, that will be your Q3. Okay? So let me change the question a little in case anyone is confused. Assuming I got another data set, another data value, 34 in the middle. Okay, now my median is 33.5, right? Can you all see that? Then how to find my Q1? I cannot throw away any data anymore because my median is not perfect. So I cut the data into 2. So now my median my Q1 for this scenario will be the median for this portion of data. Then my Q3, okay, my Q3 will be the median of the behind portion of the data. Hannah, so hopefully that clarifies any concern anyone has. This is the part where students always get confused, Q1 and Q3. All right, now part 4, mode. Can anyone tell me what's their solution for mode? Okay, just now I got hint. Mode can have more than 1 answers. So this question, there's actually a few modes lah. Okay, as you can see here, quite a few numbers appeared twice, right? And no number appeared 3 times. So your mode is 25, 32, 35, 40. Okay? So there are 4 modes. It's all right. Okay, it might look a bit weird, like 4 modes. Usually mode is like 1 or 2 only. But it's okay one. Can Okay. So construct the box and whiskers plot for the above set of data. The next part, part B. Tell yourself, box and whiskers, you need what? You need the minimum, you need the maximum to draw the whiskers, okay? You need the median, you need the Q1, Q3 to draw the box. So you need to identify all these values first. Then you can draw the box and whiskers diagram, right? Okay, can you all try on your own right now? Draw the box and whiskers diagram. Anyone has any questions so far? Don't need to be shy, huh? Okay, if previously you had the issue of identifying Q1 and Q3 from a set of data, now you go and take a look at those questions that you didn't do correctly before and try this method out on those questions. You should be able to get Q1 and Q3 correct now, if you understood what I was yapping about. Okay, anyone need calculator can let me know. I have one extra. Are you guys both from Bartley? Your school never asked you to buy the Casio calculator, is it? No. Okay, just asking, just clarifying. Okay, because later on, right, I will be talking about things you can get from the calculator. I'll be referencing to the Casio calculator. But if it's not clear, you can let me know after class, or you can ask me when I ask if you all have any questions. Okay, do you all construct the box plot diagram already? All right, so it's not too difficult. It's pretty straightforward. But the important thing is you should try to be as proportionate as possible. So what do I mean by that? Yes, you draw whiskers. Yes, you draw boxes. But can you see, for example, 25 and 21? The difference is 4, right? Versus 25 and 33, the difference is 8. The fact that the difference here is greater than the difference here, okay, your drawing should match up the proportion as much as possible. So don't go and do something like this and then so small because it's disproportionate already. You can see that? So as much as possible, make sure your drawing is as proportionate as possible to the actual data. Okay, just in case you get penalized anywhere. Everyone okay with the box plot diagram? I'm sorry, box and whiskers diagram? Hannah? Okay, part C. Calculate the mean height of a plant and the standard deviation. Everyone here know how to key in the values for standard deviation. Key in the values into the calculator to get the mean and standard deviation. Yes, if don't know, let me know. Okay, I will show the instructions for the Casio calculator version over here. Hold on. Okay, in case anyone needs it. So here are the set of instructions for the Casio yellow button calculator. Different calculator got different instructions. But why I show this one is because usually majority of the time, most of us will be using the yellow button Casio calculator. All right. So follow instructions. And why this one, I'm asking you guys to use this instruction rather than this instruction. Take note. Can you see that for this particular data set, question 1, okay, there are varied frequencies because, for example, 33 appear once, but 25 appeared twice, right? So because 25 has a frequency of 2, while 33 only has a frequency of 1, the frequency is varied. That's why you should use the varied frequency steps over here. All right. So yes, calculator will return you SD. It will also return you mean, but I would always encourage all of you to find the mean manually. Why? Because if you find the mean manually, you can check your calculator answer whether your calculator is correct or not. Okay, what do I mean by that? Let me key in everything here in the calculator first. Hold on. So I will have to, using the Casio yellow button calculator, I will have to click shift and set up and change the, and go to statistics mode. So you need to press the down button once, and then you will see statistics 2, click 2. Then I must turn on, click 1 and turn on the frequency. Why must I turn on the frequency? Because this is a varied frequency question. Then now I go to set up and I press 3 to go to statistics mode, to go to the calculator mode whereby I can start keying in data. All right. And now I select 1 to go to the mode where I can key in my frequency and data. Okay, y'all should see 2 rows. Okay, you should see 2 rows, a X and a frequency. Sorry, not 2 rows, 2 columns. X and a frequency. So the X column is where you key in the data set. The frequency column is where you key in the frequency of data. So coming back to the question, can you see that 21 appear once, 24 appear once? So I key in 21 and I key in 24. Then the frequency at the side will auto-populate. So my advice to you is key in all the data first. Okay, 25 appear twice, yes, but you don't need to key it twice. You can key it once. And then after that, then you change the frequency column to a 2. But I would advise you guys to key in all the data first, then change the frequency at the end so that you don't need to keep clicking left and right in your calculator. All right. So let me key everything in. Hold on. 32, 33, 35, 38, 39, 40, 42. Hold on. 2, 2, 2, 2. Okay, after you key in everything, don't anyhow press your calculator, because if you anyhow press, right, you might, the whole page might disappear and you have to re-key in everything. Okay, it happened to me a couple of times. So after we key in everything, when we edit the frequency already, now let's go to click option and click 3. Okay, you should see a bunch of numbers on your screen. All right, so why did I say I would always encourage you guys to do the mean manually? Okay, it's because if you key, because we key in a lot of numbers into the calculator, right? But there is a high chance we keyed something in wrongly. But if our manual mean matches the calculator mean, it means that the calculator's values are correct. So you can safely take all the values in the calculator and do your standard deviation later on. Understand what I'm trying to say? So this is like a, not say a cheat lah, but like a way you can ensure that you can trust your calculator. Okay, so I go and find the mean manually. Okay, I go and press everything, sum up together, and then I divide by 15. I get 32.6 corrected to 3SF. And now I take a look at my calculator. This thing is also 32.6. So I can be very sure that, hey, whatever I'm seeing in my calculator is accurate and I can use it to find my standard deviation. All right. Mean is very easy. You don't even need a calculator. But standard deviation, do you want to key in every single thing into the calculator manually? Not really, right? But take note, when we use the calculator method, you cannot just say SD equals to 6.46. Cannot. You must show enough working to tell the examiner that you know your formulas and you can get the working mark as well. So over here, okay, the top part, okay, I'm missing something. I'm missing a square. All right. So the top part over here, how come I know these are my values? It is because my calculator actually tells me every single value I need. That's why I say the yellow butter calculator is better, because the old model for the blue Casio calculator, it doesn't tell you this value. Then too bad, you need to go and key in manually. All right. So what is this value over here? This value from your Casio calculator is going to be the summation. Sorry, let me change color so it's clearer. Summation of x squared. Okay, can you all see there's a submission of x squared? For those of you with the yellow button calculator, this one is telling you all your observations squared and then they sum it up together. Can? So you put it into your formula, but you put the value into the formula as you're working. Okay, then how come I know this is 15? Because remember the formula is divided by the frequency, and the frequency is 15. Can see that? You can also get the frequency from the calculator. You press the button down, then you can see n equals to 15. N, the literally the alphabet n, is by default the alphabet that you will use to represent frequency. Okay? So this one we can get from the calculator. This one we can get from either reading the question properly or the calculator. And then remember, the formula is just mean square. So you just put in mean and then square it at the back. All right. Then after you have this step, this is sufficient to show the examiner that you are indeed using workings to do the question, but actually you're just using calculator. You can copy and paste this value over here from the calculator. Can see that? Sure? Okay, so the main takeaway here is you need to show enough workings for the examiner to know that you are using the standard deviation formula to indeed get standard deviation and not just blindly pressing into the calculator. All right, so for those of you who are unable to get this or any number from the calculator, unfortunately, you have to key in manually. All right, but those of you who have the calculator that can show you all the values, individual values respectively, great. And how do you ensure that you can trust your calculator? Check the mean value. If the calculator's mean value matches up with your manual mean value, you can be ensured that your data here is accurate. Another way to check is take a look at your frequency. My calculator says that I have a frequency of 15 and the question got 15 observations. So it means that I didn't miss out anything. All right, this is very useful. If you understood what I'm talking about, great. If you don't and would like to clarify, you can ask me later. Okay, so in school, they will probably teach you how to use the calculator, but they probably never teach you how to check that your calculator values are correct. So I just went through it. Hopefully you will use it and do it correctly next time. Now, let's go to the second question. Okay, this table over here, can anyone tell me what table is this called? Okay, it's your frequency table. It is not a cumulative frequency table. Okay, there is a difference between a frequency table and a cumulative frequency table. If you are ever given a cumulative frequency table, you probably have to convert it to frequency table first. Then you can start finding your mean and standard deviation. All right, how would a cumulative frequency table look like? It will look like this instead. Okay, they will say 0 to 5.
Kind of slow. She talked like primary 1 students listening, so I'm just doing it first. Then later.
Sorry, are you asking something? Okay, I think she unmuted herself by accident. Anyways, let's continue. If there's a question, you can write in the chat box first. So, okay, for a cumulative frequency table, it will look something like this instead. Oops, but my pencil like a bit no ink. Hold on. Okay, so the next one will be from 0 to 10. All right, because your cumulative frequency table is a literal accumulation. From 0 to 5 is like a value, you will get a certain amount of frequency, but the next column or the next row, it will accumulate from 10, not to 5, but all the way to the minimum value. So that's the difference, okay? A cumulative frequency table, okay, when I say no ink, it means probably no battery. Sorry, give me a moment. Let me just double check. Okay, that's battery. All right, so your cumulative frequency table, the rows will look something like this instead. But this, can you see the frequency will also be accumulated? If the frequency is accumulated, you won't be able to key into the calculator because there is a double counting of frequencies. That's why you need to be very careful on whether you are given a frequency table or a cumulative frequency table. If you are given a cumulative frequency table instead, you probably have to convert it to a frequency table first. Then you will get the true frequencies. Then you can key into your calculator. All right. So for this question over here, this is the data set. Okay. Can you see that it's a varied frequency data set again? Because for this value, the frequency is 11. For this value, okay, the frequency is 7. All right. So the frequencies are varied. So when you use your calculator, you make sure you're in the correct mode. All right. You use the correct instructions to key in the data. Now, when you see this kind of thing, you always tell yourself, the X value to pick is always right smack in the middle. All right. You don't need to care whether got inclusive or exclusive, whatever. You don't have to care. You just have to take the middle value of these two. So I will change this. I will not change this. I will view this as though X is equals to 2.5 and 2.5 appeared 11 times. I will look at this and take X as though it's 7.5 because 7.5 is the average of 10 and 5 ma. Then I will say that it has 7, the frequency will be 7. All right. Now, moving on to part A, calculate the mean time spent. Okay, mean is literally just add up everything together and then divided by the total number of observations. We can see that the total number of observations is 40 because they told us, or we can just sum this up together. All right, if it was a cumulative frequency curve, table, we will see a 40 over here. We will see a 11, we will see a 18, and we will see a 28 here instead. So can you see if it's a cumulative frequency table, the frequency will be blow up? That's why you need to convert it to a frequency table first. All right. So same thing, because my part B will probably ask me for SD. So my first part, I like to do it manually. Okay, I want to do it manually so that later on when I key in my data into the calculator, I can be very sure that I can use the SD value because my manual method matches the calculator answer. All right. So same thing, make sure you have enough workings to show that you are indeed using the SD formula when in fact you are using calculator method. So key in or write all these values in as your workings. All right. Okay, so this is the shortest way I would recommend you to present your answers lah. If you want to write down the whole entire chunk of working, also can, but it's not the fastest way because you're wasting time writing a lot of like numbers. That's why I say write these values that you can get from the calculator as your working. Okay. So yeah, use calculator to check. When I say this, it means check the mean value lah. And okay, moving on to part C. I'm assuming everyone keen already, Okay, moving on to part C. This kind of question is oftenly tested for a data question. They tell you each tourist spent 5 minutes more viewing the lion as compared to the tigers. Okay, take note, the data at the top is tigers, not lion. Please read the question carefully. How does the mean time and standard deviation, how would it differ? Anyone want to tell me? Want to tell me the answer? Can try. Wrong, never mind. Mean time plus 5. Everyone agree? Okay. Yeah, okay. So this question is, okay, literally like very standard. It will come out one. Okay, so please make sure you know how to do it. Imagine, okay, you have every person has 5 more minutes viewing the lion. So if everyone increase by 5 minutes, can you see the mean will also naturally increase by 5 minutes? Okay, but if everyone increase by 5 minutes, does the spread of the data change? Everyone increase by 5, can you see the consistency is still about the same? Because everyone increased by 5. It's not like some of them increased by 5 while others decreased by 7. The spread of the data, okay, the dispersion of the data around the mean is still consistent. Still equally consistent. That's why the standard deviation will not change. Understand? Okay, because everyone increased by 5 together. It's not like some increase by 5, some decrease by 5. Okay, this question will always change when it's being tested. So you need to be able to understand if the change, is it affecting the median value, the central tendency value, or is it affecting the dispersion? And then you answer accordingly. All right? Hannah? Okay, now let's move on to question 3. Okay, question 3, my graph looks a bit messy, okay, but it's my workings for me to do all the questions later on. So they tell you that the science examination, 1,200 students took 2 papers. So there are 2 papers, not 1 paper. I read carefully. And then this is a cumulative frequency curve to show the 2 papers, okay, the distribution of marks. For paper 1, estimate the interquartile range. Basically, they are just asking you to find the interquartile range. Do you all know how to do this question? It's pretty straightforward, right? You need to find the 75th percentile, the marks, the 25th percentile, the marks, and then you minus them to find the interquartile range. But be careful, we are looking at only paper 1. So don't go and mix up the 2 papers. Paper 1, the curve is this one. This one, okay, don't go and use the other curve. So what is the 75th percentile? Tell yourself, where is the 75th student in a way? The 75th percentile student. You take 75% times 120, you will get 900. So the position of that student is the 900 student. Can see that? And then you will look at the student position first, then you see the corresponding mark. Sorry, draw wrongly. You see the position of the student, then you see the marks. Same thing for Q1. Q1 is the 25th percentile, right? So we find the 25th percentile, the frequency first. Sorry, it should not be 30, it should be 300. Okay, the 25th percentile is at the 300 student. So we look at 300, then we look at the marks, and that is the Q1 value. Okay, then how do you find interquartile range? You take Q3 minus Q1. Everyone understand so far? Okay, for those of you who are done with finding the IQR for paper 1, can you find the IQR for paper 2? Okay, can you all do it at the side? I will need these 2 values later on to go through what I want to say. So please find it as well. IQR for paper 2. Yes, it's supposed to be 300. Yeah, I erased it again. Just now I changed it, but I erased it again. If anyone has any questions, let me know. Okay, did y'all manage to get the 2 interquartile range values? 14 and 17 respectively? Okay, can anyone try and tell me, what does this 2 interquartile range suggest? Okay, can y'all comment on the interquartile ranges? What does it mean? Okay, why am I asking you this question? Because this is a question that will likely come up. They will say, can you comment about the performance, or can you give any comment about the 2 papers? The fact that I have 2 interquartile ranges, I can start comparing the papers. All right, for those online, if you want to try answering, you can write in the chat box. Anyone want to tell me what can you say about these 2 papers? Okay, what does interquartile range represent? Okay, it represents, yes, the dispersion of data around the median. Okay, it's around the median, not mean. Be very careful. Interquartile range is always linked with median. It is not linked with mean. Okay, if you compare interquartile range and mean together in the same question, something is wrong already. It's a pair that always comes together. Median, interquartile range is together. Mean and standard deviation is always together. Okay, when we see 14 and 17 as interquartile range, which one has a smaller spread? Which one has a greater spread? You all can see, right? Paper 1 has a smaller spread of data because the interquartile range is smaller. Paper 2 has a greater spread of data because the interquartile range is bigger. Can see that? And what does it translate to a comment question? Like, what are you going to comment about the context? Can you see the performance for paper 1 is more consistent? Okay. Can you see that the performance for paper 1 is more consistent because the spread of the data is smaller? So if it's a comment question, you have to say things like that. Like, oh, because of the interquartile range is smaller or greater, then this paper, the performance is more consistent. This paper, the performance is less consistent. So if you ever see a comment question in school, okay, you always talk about two things. Either the spread of the data, the consistency, or the performance. Okay? Performance is always linked to median and mean. Consistency is always linked to IQR or SD. All right? So if you see a comment question and you can get IQR and median, it's always talking about these two, consistency and performance. All right? So, okay, let's move on to part B. Part B say estimate the candidates that gain at least 75% of the marks for paper 2. So first of all, you need to go and find 75% of the mark lah. What is 75% of the mark? Is 0.75 times 60. Okay? Why is 60? It's not because 60 over here is the maximum value. No, it's because same thing. We take a look at the cumulative frequency curve. Okay, it's not very clear, but it ends at 60. So that means the top student score full marks. Can see that? So the maximum marks is 60. All right. Then 75% of 60, you just use calculator lah. All right, it will be 45. So can you guys tell me the number of candidates that got at least 75%? You know that the marks you should be looking out for is 45, right? Okay. So take a look at 45 and take a look at the graph. 45, when you draw it up, okay, when you draw it up, the purple color line, this is the frequency, right? But if your answer is 1060, it is absolutely wrong. It's not 1060. Why? Because remember, a cumulative frequency curve is always looking at the score and below. So 1060, it is the number of students that scored 45 and below. The question say at least 75%. So you will have to take 1,200 minus 1060. So this is a very common mistake students make. Okay, you all just read from the cumulative frequency curve and then get the answer. No, remember, the curve is always looking at the score and below. The score and below. So you need to go and read the context properly and adjust your answers accordingly from there. Okay? So this is the solution over here. Some of you might be thinking, but 45 marks, right, and below is 1,060 students. So if I want above 45, shouldn't I like minus one student or add one student, something like that? You might be thinking of this. Just tell yourself, don't need to make your life difficult. For cumulative frequency curve question, it's always just take the value as it is or take the complement value. So total minus the complement value. All right? You don't need to go and care whether that one student, is it really 45 or not. Can, Okay, now let's move on to part C. Like this paper a bit too easy for you guys, is it? All right, so one additional student gained 35 marks in paper 1, but was absent for paper 2. Estimate the mark he would obtain if he had taken paper 2. This is a percentile question. Okay, you don't need to find the exact percentile. All right, But the idea is, if the student is in the top 10%, that means the student is the top 10% student for paper 1, you would naturally expect the student to be also top 10 for paper 2. So you should be looking at the percentile of the student. They tell you first paper, score 35 marks. So let's look at 35 marks. Okay, let's look at 35 marks over here. And it hits paper 1 at this frequency. So can you see this frequency is where the student is at in terms of percentile? It's at the top few percent over here. So if the student is linked to this frequency for paper 1, it is linked to this percentile for paper 1 as well. And we just need to look at this frequency. We look at paper 2, the marks. Okay, then we just draw an arrow down and we will get the score for the estimated score for that student for paper 2. So the idea here is you need to assume that if the student is like at the top 10% for paper 1, he will be at the top 10% for paper 2 as well. And how do you find the percentile? It is linked to the frequency you can find the student at. All right. So the workings for part C is the orange color highlight, if anyone is unclear. And you can get that the marks he will score is, the estimated marks he will score is 43. Okay, now let's take a look at part D. Okay, which was the more difficult paper? Justify your answer. Anyone want to tell me what is the answer? If you finish. Okay. Anyone? Okay. Every time when they ask you to justify your answer or talk about something, it's as good as a comment question already. Comment question is always about two things. Either the spread of the data or the average performance. Okay? So here, should we be talking about average performance or the spread of the data? They are asking you which is the more difficult paper. Yeah. Okay, we are asking about more difficult paper. We are not asking you about the performance of the student in general, like the consistency of how the students perform. We are asking you which is the more difficult paper. So here, we should be comparing the average performance and we should be looking at the median value because we cannot find mean. All right, so take a look at the two curves. The median for curve 1 and the median for curve 2. Okay, median is 50th percentile. So you need to go and look at the 600 student. Can see that? And we can see that for paper 1, the median score is 26. The blue line over here. And then for paper 2, the median score is 29. So since for paper 2, the median score is higher, it means that for paper 2, the paper is easier. Can see that? So paper 1 is the more difficult paper lah. Okay. You need to justify your answer. So you cannot just say paper 1. You need to go and say, oh, because the median value tells us is paper 1. Your answers need not be word for word exactly the same as this for sure. But the idea needs to be there. All right. For anyone who is interested, if the answers will be uploaded, the final answer will be uploaded, but the annotated answers will not be uploaded. All right. Okay. Yeah. I can always change part D. I can say, can you make 2 comments about the papers? If I say make 2 comments, or if the question is 2 marks, they say make a few comments, and the question is 2 marks. You need to give 2 comments to hit the 2 marks. And you will always be comparing either mean or median, and then either standard deviation or interquartile range respectively. Okay, it's confirmed mean or median or standard deviation or interquartile range one. All right. So yeah. Then the purple color question is the question that I asked you already lah. Is the which paper has a more consistent performance? It will be paper 1. Okay. So if you ever see a comment question in exam, take note, it's confirmed talking about the spread or the average performance. Okay. So yeah. Comment questions here is a summary if anyone wants to copy down. Okay, when we are talking about performance, we always look at mean or median. If we are talking about consistency, we'll be looking at SD or interquartile range. A common mistake is when students see a bigger SD, they will think that, oh, it means it's better, so it's more consistent. No, remember, what is the definition of SD and interquartile range? SD and interquartile range is the dispersion. So the bigger the value, the more spread out the data, the less consistent. Okay? So yeah, everything is over there already. Can you can always rephrase your answers, but the same idea must be there. You can say, oh, bigger value, data is more spread out, overall less consistent. Okay? Hopefully now you will have a better sense on all these comment questions lah. Is when every time you see two comments, it's always talking about these two one, confirm. Okay? Unless the question is very special. Okay. Everyone all right? Any questions so far? Okay. If it's too simple for you, great. Okay, it means that you're probably more or less quite okay with this chapter. But if you are confused at anything, you can let me know. Okay, moving on to our next chapter, probability. Okay, so probability, right, is always a value that will be biggest is 1, smallest is 0. If you ever get a probability that is bigger than 1, confirm something is wrong, check your work. Okay, it's a very good way to check your work. Sometimes you add the branch using the tree diagram, and then you realize, why my answer 2 point something? Confirm your answer is wrong, because the probability will never be, okay, bigger than 1. If a probability is equals to 1, it means that something will definitely happen. If the probability is equals to 0, it means that that thing will never happen. Okay? So this is the formula for probability. It's very important. It's the number of outcomes you want, okay? The thing you want or the thing that the question is asking you over the total number of possible outcomes. Okay? So for example, if you want to roll a 6 on a fair dice by default got 6 sides lah. If you want the value 6 to appear, it will be 1 out of the 6 sides. That's why it's 1 out of 6. For a probability of a head, for a coin toss, it will be 1 out of 2. Okay? And then drawing a diamond from a deck of cards. If you all don't know how a deck of cards is, right? Like you all don't know that there are 52 cards, 4 suits. You all need to go and buy a deck of cards. All right? Because deck of cards always is very commonly tested. Not always lah. Very commonly tested. And they won't tell you that there are 52 cards. They won't tell you that there are 4 suits. So you have to be familiarized with a deck of cards. Okay, I'm sure you all know how a dice looks like and a coin looks like, right? So that one I'm not going to emphasize. But for deck of cards, take note, there are 4 suits. Okay, 2 of the suits are red, 2 of the suits are black. All right, diamonds and hearts are red, clubs and spades are black. You need to know this because they can say, find the probability of drawing a red card. Okay, they can also say, find the probability of drawing a king card that is red, something like that. All right, so be very sure you know how a deck of cards works. There's no 1 on a deck of cards, okay? There is only ace, king, queen, jack, 2 to 10. Okay, you won't see a card number 1. And joker can ignore. For those of you who know what a joker card is, your gamble or anything, can ignore. All right, don't care about joker. So there's a total of 52 cards. 13 cards are of one, there are 13 cards in one suit. All right. So please make sure you know how a deck of cards look like. Okay, here is your probability diagram. Actually, this one is called possibility diagram as well sometimes. But anyway, it's this table lah. But take note, this table over here is always, you can only draw it when 2 things are happening at once. If 3 things are happening at once, you cannot draw this table because there's no way you can draw a 3-dimensional diagram on a 2-dimensional paper. If you can, show me. All right, so this thing over here, right? The one on the right and the one on the left. Okay, one on the left and the one on the top is basically the 2 things that's happening. They ask you to sum up the faces of 2 dice. So this one is dice 1 and this one is dice 2. Then if the observation is 1 on the first dice and the observation is 1 on the second dice, then the sum is 2. Okay, some questions that I will commonly have. Can I swap the 2? So this is the first dice instead, and then this is the second dice. Yes, you can. The order doesn't really matter. unless the question emphasizes. But take note of the 2. This one is asking you to sum the face of the 2 dice, but this one is asking you the number of faces showing an even number. So your entries over here will be slightly different. You need to adjust your entries accordingly to answer what the question is asking you to find. Okay, over here, because for example, if I draw a 3 and I draw a 2, the sum is 5. But here, if I draw a 3 and I draw a 2, it means that one of my face is an odd number and one of my face is an even number. So at the end of the day, only one of the faces shows an even number. That's why the entries here are 0, 1, and 2 only. Okay, take note, something that you can use, you can use to check this diagram over here is usually this diagram got some sort of mirror image trend happening. Okay, for example, you see, can you see that it's kind of a mirror image if you draw a diagonal line like that? Can you all see that? Usually for this diagram over here, there's a mirror image thing happening. If you see that your entries, right, somehow there's no mirror image, right, it means that probably one of your entries, you made a careless mistake. All right, same thing over here. If you draw a line down, okay, you'll realize that there's a mirror image about the line. Okay? All right, okay, now, tree diagram. Tree diagram is actually the more useful diagram out of the 2. You are expected to know how to draw both, because the question can say, I want you to draw a tree diagram, or I want you to draw a possibility or probability diagram. So you need to know how to draw these 2. And even if the question never asks you to draw a tree diagram, all right, sometimes it is good to draw it at the side for your own rough working, because it can help you visualize what is happening. Okay, I wouldn't really advise you to draw a possibility diagram on your own, but a tree diagram, you can always draw it on your own to make your life easier. Okay, so draw diagrams to help you even if you are not asked to. Take note, for a tree diagram, a common mistake students make is they swap these 2. Okay, probability is always on the branch. Outcome is at the end of the branch. Okay, don't swap the position of the 2. If you swap the position of the 2, you will not get the full marks already if the question asks you to draw a tree diagram. All right, so how do you get the outcome of 1A? 1A is at the end of the branch. So how to get the probability of this thing? You will take this times this to give you this. Across a single branch, okay, a single branch is always a multiplication. But if you want the probability of 2 branches combined, it will be an addition. Okay, a single complete branch is always a multiplication, but if we are looking at 2 or more branches, it's an addition of probabilities. Be very careful. All right. So you can notice that actually all the outcomes, the probability add up together equals to 1. Because if you have, for example, MCQ question, all right, you only have 4 options. The probability of you picking each option sum up together must be 1, because you must pick. Don't tell me you never answer the question, assuming that you answer the question. All right. Okay. So everyone here should be clear on what is without replacement, right? Okay. So be very mindful. Without replacement means that there is no replacement, of course. And then if there's no replacement, your numerator and your denominator will both be affected for sure. Okay, this Venn diagram is for later on. It's not for the without replacement one, so ignore it for now. Take note, a common mistake student have is this. Okay, over here, you all put half because probability of drawing a red ball is 5 out of 10, right? Then it's also half, so you all put half. Then the next branch, you all tell me is 0 out of 1. Okay, because minus 1 ball, minus 1 ball. This is a common mistake, but take note, your half is not number of balls. Your half is the simplified probability already. So you should be looking at 10 balls in total, become 9 balls. Okay, it's a very common mistake. Okay, another question that I will usually have is, do I leave this in a simplified fraction or I can leave it as 5 over 10? Usually both are accepted. Okay, but to play it safe, leave it in simplified form. All right, because simplified form, they can never fault you. But if you don't simplify it, they could fault you. You never know. But take note, if you leave it in half, don't go and do that 2 ball become 1 ball thing lah. Be extra careful. It's actually still 10 balls become 9 balls in total because I draw 1 ball already. All right, can now? Okay, so moving on to rules of probability. This thing over here, some of you might learn this in school, some of you might not. All right, but if you have not learned this in school, tell yourself, these 2 formulas are very useful. I'm going to go through it today. Okay, and I will show you that you can use these 2 formulas as an alternative way to do probability questions. You don't need these 2 formulas to do the question. Okay, you don't need them. But if you know them, you have 2 options to help you answer a single question because you have learned 2 methods. Okay, anyone here seen this probability formula before? See before? Okay, some yes, some no. This used to be in the older syllabus, but now they move it to JC. All right, you all have it easy. Okay, you don't have it in your current syllabus anymore. But don't worry, even though it's not in your current syllabus, you can always use it to help you do a question. This question, you all know union and intersection, right? This one is Venn diagram, you all should know. This formula actually comes about from your Venn diagram. Your Venn diagram explains this formula. So the union of AB is equals to A, probability of union. I'm just going to skip the word probability, equals to A plus B minus the intersection. Okay, why? Take a look at this over here. It is A and then B, right? So this is how A looks like. This is how B looks like. If you add these 2 up together, can you see that there is an overlapping? This piece appear twice. That's why you need to minus 1 piece, 1 of it away to get the union. Can see that? Okay, because when you add the A and the B, this center piece is counted twice. There's an overlapping, so you minus it away. This is how this formula comes about. All right. Then this thing over here. Sorry, it's a bit laggy. This thing over here is your complement formula. This formula is super useful when you see a at least question. Every time you see at least in a probability question, you might want to think of this method. Okay, later we'll go through a few examples. So this one is saying, okay, you can also be described using a Venn diagram. So probability of A. A prime is this entire thing, right? So the probability of you getting something of A prime is just the whole thing minus the probability of A. Can see that? Using context as an example, if I tell you there are only boys and girls, the probability of drawing a not girl is the 1 minus the probability of drawing a girl. Can see that? Like picking a girl. All right? So these 2 formulas are really useful. Okay, you don't need to use them, but if you have them, it can help you simplify a few questions. Okay, moving on to point 3. When considering separate events, we add the probability. This is the case, this is the scenario when we are looking across branches. When we are considering one outcome and another outcome, we are adding the probabilities together. Okay? Then, for point 4, when we are looking at 2 events within the same case, that means there's only one outcome, but there is more than one thing happening before we get that one outcome, is we are looking at a branch with more than one layer. And to get the probability, it will be the probability of layer 1 times the probability of layer 2. Okay, that's why it is a multiplication. For example, when you're drawing cards twice, okay, you're drawing 2 cards, okay, I ask you maybe what is the probability of drawing an even number twice? Sorry, not cards, rolling a dice. Let me change an example. So for example, I say I rolled a pair dice twice. What is the probability that both dice shows an even number? Okay, it will be 3 out of 6. Times 3 out of 6 because it is one event at the end of the day, even number, but there are 2 dices that I need to consider. So the first dice multiply by the second dice, the probability. Okay, so that's what's happening. Then for point 5, I already mentioned it just now. Probability of 1 is a sure event. Probability of 0 is a event that will never happen. All right. Now let's move on to the question over here. Question 1. They say a card is chosen at random to form a pack of 52 playing cards. Okay, so it's your regular deck of cards. Find the probability that the card drawn is either an ace or a spade. First thing to ask yourself, ace got how many cards? 4, right? Okay, it's already here lah. King got how many cards? 4. So it's just 8 out of 52. Simple as that. But leave your answer in simplest form. If you don't leave your answer in simplest form, confirm you will be penalized. Okay? I'm sure you guys can do part B as well. Find the probability of a spade or a diamond. How many spade cards are there? One suit got 13 cards, right? So a spade is 13. There are 13 spade cards and there are 13 diamond cards. So the answer will just be 26 out of 52, which is just half. You can also view it as 1/4 plus 1/4. Why? Because 1/4 of the cards will be spade. 1/4 of the cards will be diamonds. So you can just view it like this as well. Okay, it doesn't matter which way you choose to do it. The answer, the most simplified form, will be the same. Okay, part C. Can you all do it and tell me the answer? Sorry? Okay. Okay. Part C is where students start to make mistakes. All right. One way to do it is the direct way without using the formulas that I've taught. Okay, just now I taught two formulas, right? The union formula and the complement formula. Let's do the direct way first. For diamond or a king, can you see that there are 13 diamond cards? But out of these 13 diamond cards, one of them is already a king. So the number of king cards left will be 3. Then it's 13 plus 3, 16 over 52. Can see that? But you have to leave your answer in simplest form. So you need to go and simplify accordingly. So this is the direct method. You think of the overlap before you even answer the question. But let's use the other formula that we have just learned. The other formula that we've just learned looks like this. We consider the probability of drawing a diamond. We consider the probability of drawing a king. But remember, there is one overlapping card, an intersection between a king and a diamond. So we minus the one card and we can also get 16 over 52. All right, so now last time you probably only learned this method in school, the direct way. But because now you know there's this new formula, you can use this new formula as your go-to method. Or if you have time in exam, do both. Then you can check your work. Okay, it's really not that difficult to do both lah. Honestly, each method like 3 seconds max. All right. Can see? Okay, if this is new to you, great. If it's not new to you, also great. That means you already learned this before and you can use it. Okay, common mistake is, right, you all forget about the overlapping card lah, diamond and king. So take note, check your work. Ask yourself, are there any overlaps? Don't have, then move on. If have, make sure there's your answer takes into account the overlaps. All right? And question 1C, okay. Then next question. 2 cards are drawn consecutively to form from this same deck. Draw a tree diagram to show that the probability that both cards are hearts is 1 over 17. Take note, is there any replacement? Don't have. So when you draw your tree diagram, you need to adjust the denominator as well because there is no replacement. This tree diagram, okay, don't make your life miserable by thinking of a complicated scenario. Your branches should just be heart and no heart. Don't need to go heart, spade, diamond, clubs, don't need, because there's no use for it. You're not being asked to find diamonds or spades or anything. You are just simply asked to find hearts. So your tree diagram, each layer meaning each draw, should only have 2 branches. Okay, can you all try drawing this on your own right now? Okay, for those online, if you all can you all leave only at the end of the session? Because I need you guys to do a survey later on. All right, it'll be good if you can stay till the end. Same thing, if any questions can let me know. Today's session very quiet. All right. So this is how your tree diagram should look like. Take note of the presentation. Okay, probability is on the branch. Outcome is at the back of each layered branch. And you should say draw 1 and draw 2 to show that this is the first draw, this is the second draw. Okay, as much as possible, your tree diagram should be very structured, like not like slanted sengit. No, it should be as beautifully shaped as possible. Okay, just now I forgot to emphasize something. The presentation over here is important as well. Take note, it's a P bracket, what you want to find. A P bracket, what you want to find. If you just throw the examiner this part without writing this, you will be penalized. Because they can ask you, what is 2 out of 13? What are you writing? Okay, you need to show the examiner explicitly that 2 out of 13 is the probability of an ace or king. So take note of your presentations. All right, so this is your tree diagram. Then show that the probability that both cards are hearts. How many branches you need to consider? Only 1, right? Can see that, which is this branch over here. So a probability within one single branch is just this times this. Okay, this question is what I like to call a confirm full mark question. Why? Because the answer is already provided. Okay, they already tell you it's 1 out of 17. If you don't get 1 out of 17, it means that there's something wrong with your work for sure. Okay, it's not the question, it's you. So if you get 1 out of 17, great, you don't even need to check, you can move on. But please take note, draw this properly lah. Okay, make sure you don't make any careless mistake over here. Okay, even though we are only using this branch, every other branch must be correct because the marks also come from drawing a tree diagram. Okay. Okay, hold on. Another question I want to ask you guys. Hold on. Okay, probability of drawing at least 1 heart. Okay, if I have an additional question, I ask you, find the probability of drawing at least 1 heart. Can you all tell me how would you do it? Anyone want to tell me? Okay, now the question is the probability of drawing at least 1 heart. Can anyone tell me how would they do this question? Yeah, okay. So there are 2 ways to do this question. But remember, there's a keyword, at least. Every time you see at least, you might want to think of an alternative method that could be easier. Okay, so the direct method, let's go through the direct method first. At least 1 heart, can you see that there are 2 scenarios you need to consider? 1 heart and 2 hearts. So the direct method will be taking this probability plus this probability plus this probability. Can see that? This is the direct method. But the complementary method, can you see that this thing over here, at least 1 heart, is simply just 1 minus 1 minus no hearts. Can see that? So instead of taking so much time trying to find the probability of 3 branches, why not just find the probability of 1 branch and then take 1 minus it? It will make your life a little bit easier. Okay? Or you could use both methods in exam and then you can check your work because both methods must be the same. Okay? Both of the answers must be the same. All right? So yeah, the solution is 15 over 34. Hannah? All right, so if previously you are very used to the direct method, maybe next time when you see a question again, at least question, you want to try both methods. Then you see which one you prefer. Then next time that's your go-to method. Okay, if there are many, many branches, like for example, 8 branches, the complement method is going to make your life a lot easier. Okay, because if you have 8 branches, you need to consider like 7 if you do the direct method. Hannah? All right, now let's move on to the next question. Question 2. Okay, they tell you that there are 9 chocolate biscuits and 8 oatmeal biscuits in a container. Sherry takes a biscuit at random and eats it. Then Dawn takes another biscuit at random from the container. When you read this, you should tell yourself that there are no replacement. Okay, they never say they refill the container. So by default, it's always no replacement unless they say something. They ask you to draw a tree diagram to show the probability of all the possible outcomes. Can you all draw the tree diagram on your own right now? Okay, remember probability on the branches. Okay, it is okay if you leave your probability on the branches in not simplified fraction, but if you want to play it safe in school or in O levels, simplify it. Okay, my solution here or the answer key solution here is not simplified lah, but you can simplify it, nothing wrong. Okay, it will be better. Okay, because I use C and O instead of chocolate and oatmeal. So it will be better if the answer key had a legend that explains that, oh, C means chocolate. Okay, I don't know why the Apple Pencil like not working. O means oatmeal. Okay, if you are done with the tree diagram, I mean, you can try part I on your own as well. So find the probability that both selects a chocolate biscuit. For this question, since the tree diagram is already out, you must as well use it, right? You don't draw the tree diagram for fun. If it's already out, use it to help you with the question. This question can be asked without part I. Okay, they don't include part I and they ask you I straight away. So these are the type of questions whereby I mentioned before. Sometimes the question need not ask you to draw a tree diagram. But if you cannot visualize what is happening, you can draw the tree diagram on your own. All right? So if this question, they test you without part I, okay, they just say immediately, find the probability. Then you can do it without a tree diagram by visualizing what is happening in your head, or you can just draw a tree diagram out and help yourself. Okay? So both select a chocolate biscuit is super straightforward. It's just one branch. Everyone can see, right? It's just chocolate and chocolate. So it's one branch. Take note, because we draw one biscuit, so the denominator will also fall. Then because previously was a chocolate biscuit, right? So the chocolate biscuit will fall, but the oatmeal biscuit will not fall for this branch. Can see, yeah? Okay, too simple already. Part B, Dawn selects an oatmeal biscuit. For Dawn to select an oatmeal biscuit, how many branches do we need to consider? 2, right? Yeah, it's pretty straightforward because the tree diagram is already out. If the tree diagram is not out, okay, same thing, you can draw it out for your own reference. Okay, you can draw a tree diagram even though the question never asks you to. But if you are very strong in your visualization, you can just visualize the tree diagram in your head. Okay, you can tell yourself, oh, for Dawn to select oatmeal, there are 2 scenarios. Why? Because Dawn oatmeal, Sherry chocolate, or Dawn oatmeal, Sherry also oatmeal. Then you can also just do it without the tree diagram as well. Okay, so the solutions for part B is 2/5. Okay, for part C, They say both select different biscuits. Okay? How many branches do we need to consider for both to select different biscuits? Okay? For both to select different biscuits, a common mistake is students only look at one branch, but you should be looking at two branches. Why? Because for both to select different biscuits, there's two scenarios. Sherry chocolate, Dawn oatmeal, but you also need to consider sherry oatmeal, Dawn chocolate. Can see that? So there are two branches you need to consider for this question, and therefore you find the probability of one branch, find the probability of the other branch, and then sum them up together. Take note of my presentation over here. Within a branch is always multiplication. Multiplication. When you are adding across branches, is a addition. Okay? Take note, So here I got COCO. I mean COOC. I'm trying to say sherry chocolate, Dawn oatmeal, or sherry oatmeal, Dawn chocolate. Okay? All right. Moving on to part D. Okay. At least one oatmeal biscuit. So the keyword at least has appeared again, right? So there are two methods you can consider, the direct method or the complement method. At least one oatmeal biscuit. For the direct method, it will be one oatmeal, two oatmeals. Can see that? Okay. For the complement method, it will be 1 minus 0 oatmeal. Okay. So for the complement method, it's very straightforward. But for the direct method, some of you might make mistakes over here because one oatmeal, remember, there are two cases for one oatmeal, sherry oatmeal or Dawn oatmeal. So technically, there are three branches in total. Can see that? It's not one branch, sorry, it's not two branches only, two oatmeal and one oatmeal, but two oatmeal is one branch, okay? Two oatmeal is one branch. One oatmeal got two branches, one branch, one branch. Okay, but why for my direct method? My working might look a little different from yours. Why is it so short? Okay, why I got 8, I don't have a times over here. It's because, can you see for the direct method, I am looking at this, I am looking at this, I am also looking at this. Can you all see that? These two branches, can you see, will come out from this one branch? And the branches were the probability, oops, sorry, give me a moment. The branches, the probability, can you see that these two add up to 1? Because the probability already add up to 1. So if I consider these two branches separately, okay, if I consider them separately, wouldn't I already take the entire branch from here? That's why here I don't need to go and waste time and get into the second layer. I can just take the first whole layer because this whole thing is included in my answer. Can see? Okay, so this is how you can save time in exam. If you go and do you split them up, right? Nothing wrong lah. It's just you waste a bit more time doing extra workings, but nothing too serious. All right, this is how you do this question over here. Everyone okay? And then I'll move on to question 3. Hold on. Not question 3. Still got one more part. Okay. Part I. Can you all try on your own first? Let me show the solutions again for the previous part, if anyone needs. For part 3, can you all try on your own first? Yeah, sure. Okay, can you all try part 3 on your own? Okay, I'm asking you all to try on your own for a reason. I will walk to the back, but I'm trapped. All right. Okay, why did I ask you to do part 3 on your own? It's because part 3 is a very common question. All right. Usually they like to ask you this kind of thing. Tell yourself, if they ask you a question whereby a numerator and a denominator will be affected together, okay, you always need to introduce an algebraic term, standard one. You have to introduce like a k, a n, a x, a y. Okay, why did I say that this question, your numerator and denominator is both affected? Because they say, how many more oatmeal biscuits must be added such that when Sherry draws an oatmeal, this is the probability. Can you see the addition of this new oatmeal biscuit will affect the numerator for oatmeal? And we will also affect the denominator for the total number of cookies. Can see that? So every time when there is a thing that appears that affects both a numerator and a denominator, there needs to be an algebraic term being introduced. So over here, I will say, let n be the number of oatmeal biscuits added. Okay? Once you have this algebraic term out, this question will be a lot easier. Okay? So, can you guys see? Currently, there are 6 oatmeal biscuits, right? So, if the new oatmeal biscuits added, I let it be n, this will be the new numerator. Then, the new denominator will be 15 plus n. Can see that? And this must be equals to 10 over 19. Can you solve the value for n over here? Now that we have one equation, okay? If you are a math student, you should be very clear that this is definitely enough because one equation can help you get one unknown. One equation is formed, you can definitely solve for one unknown, okay? So, don't go and tell me this, 15 plus n equals to 19. I mean, by right, yes, but you cannot assume that this is always the go-to method because this fraction, what makes you think that it is simplified? It could be over 38. Can see that? It might not be over 19. So you cannot tell me 15 plus n equals to 19. No, this is a common mistake. You must go and do your cross multiplication. All right? Okay. Yes, you do cross multiplication, but I don't like to say cross multiplication because every time students start doing cross multiplication when you cannot do cross multiplication, what I like to say is you need to multiply throughout by this denominator. That's why you need to multiply both sides by this denominator. Okay, you need to multiply by 19 on this side to get rid of 19. So you also need to multiply this side by 19. That's why there's a 19 over here. Okay, this is how I like to view it. You do it on one side, you also must do it on the other. Yes, it is cross multiplication, but I don't want you all to just cross for fun. Okay, cross for fun will make careless mistakes somehow. Because there are some questions that cross multiplication is not supposed to be your working, but you also cross because you get used to it. So can you all see the answer is 4? And do you all know why? Okay, yes, 15 plus 4 equals to 19, yes. But this one is by luck. It so happens that the fraction here is simplified. But you cannot assume that it's a simplified fraction all the time. Okay? Now, let's move on to the next question. Everyone clear now? Okay, next question. Question 3. They tell you a bag contains X red marbles, 12 yellow marbles. Probability of drawing the red marble is 2 over 5. Calculate the value of X. This question is actually quite similar to the oatmeal last question. But instead of you having to say, let X be the red marble, they already tell you X is the red marble. So all you have to see is X over X plus 12 equals to 2 over 5. Can see that? Then can you solve for X? Yes. Okay? This is the question whereby you see, you cannot just say X equals to 2. Okay? You can't just say X equals to 2. Okay? If X is equals to 2, 2 plus 12, do you get 5? No, right? So don't go and assume that the denominator and numerator, you can just copy and paste. You need to do that cross multiplication thing again. All right? Okay, if you're done with A, can you guys try part B on your own? Okay, if two marbles are drawn, find the probability they are of different color. How many scenarios do you need to consider? Okay, some of you are already on the right track. If you cannot see the number of scenarios to consider, visualize a tree diagram in your head or draw out the tree diagram. Yes, it's a bit waste time because you don't need the tree diagram. But if you cannot answer it, just draw it out. There's no harm doing so. Okay, if you draw a tree diagram out, you will see, right? First draw yellow, second draw red. Then you will have another two draws. I mean, another one draw, right? So this is the tree diagram you should visualize in your head. Two different colors. Can you see there are two branches to consider? Not just one, there are two branches to consider. So that means there are two scenarios you need to consider. Can see that? First scenario is yellow, red. Second scenario is red, yellow. Okay? So there are two scenarios you need to consider. If you cannot visualize the number of scenarios to consider, don't be lazy. Draw out the tree diagram. It will help you. Even if the question never ask you to draw the tree diagram. Okay? So the answer for X for part A is 8. And then here's my solution for part B. Take note, because there is no replacement, the denominator will change for the second draw. Okay? Okay? If you all can see that the probability is the same, you can also just take this times 2. But not all the time is times 2. So you only can do the times 2 method when the two probabilities are equal. All right? So this is how you will do part B. Any questions so far? Don't have. This paper too easy already. Okay, maybe we should have set a harder paper, but we are trying to go through key concepts and key questions. The oatmeal question is one question that will always appear the last part. Okay, it has appeared again in this question. They tell you why more yellow marbles are added into the bag. Okay, and then they tell you the probability change. Calculate the value of y. So this question is actually the same thing as the oatmeal question. The oatmeal question asks you how many more oatmeals are added, right? This one is just asking you how many more yellow marbles are added, lor. But this question very kind. They already tell you that you need to bring in an algebraic term, which is y. So you don't need to go and say, let yellow marbles added be y. They already tell you it's y. So can you all do this question on your own right now? Okay, can you all try on your own? It's exactly the same as the oatmeal question, and a bit similar to part A for question 3. Sure, you're okay? You're very quiet. If you're done with the question, of course, you can move on to question 4. Okay, because today, hardly any questions, we have time to complete the paper. Usually for the other sessions, we only have time to finish until question 3. Okay, so just to show the solutions for part C, can you see that this is the first step? The numerator will be 20 plus y because you have 20 marbles at the beginning, right? Can see? You got 20 marbles at the beginning. Then 12 of them were yellow. So it means that if you add the yellow marbles, it will affect both the 12 and the 20 to give you 15. Then same thing, don't go and tell me 20y is equals to 15. No. All right, if 20y is equals to 15, y is a negative 5. And that's obviously wrong. So don't go and do this again. please do your cross multiplication. And then your y is equals to 10. Okay, a common mistake is, you know what students will do? Instead of saying 12 plus y and 20 plus y, they tell me this instead. Because probability of drawing a red marble is this, right? So probability of drawing a yellow marble is 3 over 5. Yes? Then they tell me this. 3 plus y over 5 plus y. This is incorrect. Why is it incorrect? Because y is number of marbles, right? But 3 and 5, are they number of marbles? No, they are a simplified probability. So you cannot use 3 and 5. This is a common mistake, all right? It's the exact same mistake as I mentioned at the beginning of the class. When you draw a tree diagram, you can leave your answer in simplified fractions. But you must always tell yourself, the simplified fraction is not a true indication of the total number of objects. So you need to be very careful. Okay? Anna? Okay, now let's move on to the next part. Question 4. Question 4, they tell you that a bag contains 5 identical cards numbered 2, 3, 4, 5, 6. 2 cards are picked at random without replacement. Draw the possibility diagram. Yeah, usually it's called possibility diagram. To show the possible outcomes. So besides knowing the tree diagram, you also need to know the possibility diagram. This question, they never say that they are summing up the numbers, right? They never say that they are multiplying the cards. So because they never tell you what they are doing with it, you just have to draw the entries of the probability or the possibility diagram. Okay, so this is how your possibility diagram would look like. Take note, even though there are like 25 columns, there's only a total of 20 outcomes. Okay, why is there a total of 20 outcomes? Because are you drawing the cards with or without replacement? Without replacement, right? So you cannot draw the same card again. Every time when it's a without replacement question, for a possibility diagram, you should expect a gap. Okay, you should expect a gap. If you don't have a gap and it's a without replacement question, time to check your work, confirm something a bit off. Okay, I'll give you all some time to draw this diagram. Personally, I really hate drawing this because it's very waste time. All right, but you have no choice. If the question asks you to draw, you have to draw. Okay, make sure you draw it correctly because they never tell you that they are summing or adding or maybe counting the number of even numbers for this scenario. You just have to draw out the entries. Okay. Okay. Everyone still drawing? Okay, still drawing. Take note, total number of outcomes is 20, not 25. Why am I emphasizing total number of outcomes so many times? Because remember, for every probability you find, what is the denominator? The denominator is total number of outcomes, right? So if your denominator for your later questions are 25, something is a bit weird already. Okay. All right, let's do part A now. They say, find the probability that both cards shows an odd number. Okay, both cards shows an odd number. When you have the diagram out, use the diagram. It's already out anyway. For both cards to show an odd number, can you see you only need to care about this and this and this and this? Because they must be odd numbers, both of them. So you shouldn't view the whole entire diagram. You should narrow down which columns and rows you need to consider. And can you see there are only 4 crisscross intersections? Can you all see that? There's only 4 intersections, right? And some of the intersections are empty, right? So how many intersections are not empty? 2. So your answer is just 2 out of 20. Not 2 out of 25, it's 2 out of 20. Can see that? If the diagram is out, use the diagram. Don't go and try and complicate things by trying to picture it in your head. It's already out. Use it. Okay? Okay. So part B, they say neither card shows a prime number. In other words, both are not prime numbers. Can see that? So same thing, use the diagram. It's already up. Is 2 a prime number? Yes, yeah. Okay, 2 is a prime number. 2 is the smallest prime number. 1 is not a prime number. You need to know this because they are not going to recap with you what is the definition of prime numbers. Is 3 a prime number? Yes. Okay, 4 is not a prime number, right? So we highlight the column. Okay, is 5 a prime number? Yes, okay. 6 is not a prime number. Hopefully you all know. Same thing. Where are the intersections? Here and here, right? There are 2 intersections here, but it's empty. So same thing, your answer will be 2 out of 20, and the answer is 1 out of 10. Okay, the answer will be, the question, same thing, I add another one. I say, find the probability of either one of the card is a prime number. Same thing, either one being a prime number is that at least question already. Can you all see that? Because at least one of them is prime. Instead of using the word at least, I use the word either. So I can use the complement method again. All right? Hopefully it's clear for everyone. Then, now let's take a look at part C. The sum of the numbers is 8. Okay? Sum of the numbers is 8. You need to consider every single scenario whereby you can get a sum of 8. Can you all see is 3 and 5 and 2 and 6? Can see that? Okay, so 3 and 5, 2 and 6. But take note, 2 and 6 is one possible addition, but there are 2 scenarios within 2 and 6 because it can be 2, 6 or 6, 2. Can see that? So the total number of scenarios you need to consider for this 2 and 6 is 2. And then the total number of scenarios you need to consider for 3 and 5 is also 2. So that means there are 4 possible outcomes, 4 out of 20. So your answer is 1 out of 5. You could also use the possibility diagram and highlight, but take note, when you highlight, you cannot highlight 2, 3, 5, 6 together. You must highlight 2 and 6 together at once, 3 and 5 together at once. Okay, because you only can consider 2 and 6 together. You cannot consider 2 and 3 together. All right? Okay. Part B, the difference of the number is 0. Okay, this is, everyone know how to do? Too easy already, right? The answer will be 0. Why 0? Because there's a replacement or no replacement? No replacement, right? There's no way you can draw the same card again twice. So the answer is just 0. You don't even need to do anything if you understood the idea of no replacement. Hannah? Okay. Then part E, they say the product of the numbers is more than 15. Same thing, you need to consider every single scenario before you start finding the probability. Because they say product of the number is more than 15, I like to view my order from biggest to smallest. Okay, I'm not randomly thinking, oh, 6 times 5, then maybe 5 times 4. It's not by random. I like to order it from biggest to smallest. Why? Because when you order it in a way, then you won't miss out any possible situations. Okay, if you start jumping around, it's very likely that you will miss out one or at least one of the possible scenarios. Can see that? So you have a few scenarios over here, 6 times 5, 6 times 4, 6 times 3. 6 times 2 cannot, right? 12, smaller than 15. So we move on to 5. 5 times 6 is already out. So 5 times 4. Okay? So these are the 4, because 5 times 3 is 15. 5 times 3 is 15, cannot include because we want more than 15. So open your eyes big, big, they say more than 15. All right. Then over here, you have 4 scenarios to consider. But take note, the order of the scenarios matter as well. 5 times 15 is one possible situation. But, 5 times 15. 6 times 5 is one possible scenario. But it can also be 5 times 6. So within each possible scenario, there are two probabilities you have to consider. So at the end of the day, it's 8/20. Can see that? And therefore, your answer is 2 out of 5. All right. Anyone has any questions so far? Okay, great. Okay, we have come to the end of the content. Okay, but for those online, please stay. Okay, because I need you guys to help me do a survey. Quite very short one, okay? So for those physically, I also need you guys to help me do the survey. If you have any questions, you can stay back after class and ask me. So yeah, if you are interested in joining us, here are some information. Okay. Usually students don't really care about this way because they are like existing students, but I think you are not existing students. So here are some information. If you are interested to join, same thing, no pressure. It's just to let you guys know. We have a lot of snacks, as you can see outside. And yeah, everything is provided for our regular tuition classes. If you are interested to join my class, here are the list of my classes. Okay, most of them are A Math and IP because I specialize more in A Math. But yeah, I have E Math classes as well. So if you are interested, not just for math, also for science, you can let the admin know. Our admin contact number can be found on the OVERMUGGED website or somewhere. All right. Or you can let me know if it's math related. Here's my contact number. The first trial lesson is free. So if you are interested, please utilize that. Okay. But only the first trial lesson. So for every subject, only one, you can get one trial lesson only. There's a record one. So yeah, I cannot play shit lah. All right. And then here are the list of my classes. Then that's all. And I need you guys to help me do this survey. Okay. So if you like the lesson, you can say. If you don't like the lesson, you also can say. You can be honest, give negative or positive feedback. We are always open to that. Okay. But if you like it, don't say you don't like lah. If anyone has any questions, you can feel free to let me know. If not, yeah, free to go. Thank you. Okay, it's very late already, so get back safe. Okay, bye-bye for those online. Okay, hopefully y'all don't get lost at this area.